Okay, so we are on Module 1, Lesson 5, the last lesson of the week. So congratulations on being 1 week in so far to integrated math. Today we're going to talk about patterning and real-world problems that we can be represented by the equations that you guys have been using on your equation mat. So this pattern right here that we see, if I asked you in your own words to explain to me what's going on or what's growing in this pattern, there's a couple different ways you can explain it. Like for me, I'm going to look and say, well, I see a growth of, it looks like 4 flowers here and maybe an extra 1 there. That's how figure 1 to figure 2 looks to be changing to me. I want to make sure in figure 3 that that same pattern holds, and it looks like it does. It looks like it grew by another 4 flowers here and 1 here. The other way I could do it is by math, like mathematically, what do I see happening? How much is it growing by each time? Well, if that's the case, if I'm seeing that same number, it looks like it's growing by 1, 2, 3, 4, and then a 5th one there. And this one's growing by 1, 2, 3, 4, and a 5th one there. So really I should see this growth of 5. If I look here, I have 5 flowers. I want to make sure that in the next one I have 10 then, if it's really growing by that. It looks like I have 8, 9, 10. Yep, it's growing by that many. So then the next one should have 15 if it's also growing by 5. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Sure enough, it is 15. So that pattern is holding of a growth by 5 each time. That's what we're going to talk about today. We're going to look at a different one with an equation that we're given as well for patterning. This right here is another kind of problem. It says the cost of tickets to a weekend concert are $68 each, but the ticket agency charges a total of $8.50 like for their fee, no matter how many tickets you buy. That's actually pretty nice. It's not $8.50 per ticket, right? It's just a flat fee of $8.50. If X is used to represent the number of tickets, then this would actually be the equation here. We would have Y, or like the cost of a ticket, is $8.50 plus $68 times however many you get, times X, how many tickets you get. A Girls Explorer troupe spends $824.50 to buy tickets for this concert. What we're going to do is we're going to actually solve the equation to see how many tickets they bought. How many X's did they buy? Okay, so I'm going to flip my camera over so that you guys can see my document camera and see a little bit of my work and thinking on this one. So what I would do here to set this up is what we have is this is our Y, the 824. That is our dollar amount, right? So I have 824.550 is equal to 850, 8.5. I can add the zeros if I want, but I don't have to have them. And then plus the $68 per ticket that we pay for this. Again, my goal here is to solve for the X. Figure out how many tickets I bought. So my first thing that I'm going to do is grab my cell phone calculator. They're pretty glorious, right? And I am going to take my 824.5. I'm going to subtract 8.5. That's going to give us $816. $816. So I got rid of the convenience fee because I have to pay that no matter what, right? So like that's gone. And now that equals $68 ticket times however many tickets we have. To solve for X, I'm now going to divide by 68. 68. So I take my 816 and I divide by 68. And I get 12. X equals 12. I never will leave these without double checking to make sure that I've done my math correctly. So I'm going to actually plug it in here. So I'm going to take my 68 times my 12. 12 tickets, 12 Girl Scout tickets. That's $816, but I need to add the $8.50 convenience fee. And sure enough, I get 824 on this side equals 824, or I'm sorry, yeah, 50, 2450. 824.50 is equal to 824.50. And we know that we did that correctly. It means that there are 12 Girl Scouts in this troop. Okay. So next, we're actually going to go on to CPM. So I'm going to get into here and we're going to do another patterning problem from CPM. Here is the patterning problem that we're looking at. It says study the pattern of these big C's below. They're giving us an equation of Y is equal to 6x plus 3. But I'm hoping to kind of break that down based on the pattern so that we can see why. Like, what is the x? What is the y? What does this all mean when I'm given some equation like this? And how does that represent what's going on right here? Okay, so I'm going to use the e-tool. I'm going to use the e-tool. Let me drag it off again and adjust the size just so we can look at it. So here is an e-tool that they gave for this problem. You'll see figure 0. Ooh, that's weird. I wonder what that means. We have a figure 4. I can kind of see that, well, that one we probably would want to build the next figure to figure out how many there are. So we have this going on right here. Here's figure 1, figure 2, figure 3. The first thing I want to do is look at figure 1 and figure 2 like we did in our last patterning program and see how much it's growing by. So the way that I see this is I see that here's a C. I've added 1 row here, 1 row here. But I've also grown my C here too by, it looks like, 2 of them. So what I see happening is I see 1, 2, 3, 4, 5, 6. 6 being added. So in figure 1, so I'm going to kind of break this down. In figure 1, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 tiles. In figure 2, so this is my figure. I'm kind of making a table, right? Like that's kind of the idea here. In figure 2, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that's a growth of 6 plus 6 that we saw. Okay, well now I'm going to go to figure 3. How does figure 3 grow from figure 2? Well, it looks like I again can add these two, and it looks like it grew by 1 more on either side here too, because I have 1, 2, 3, now I have 1, 2, 3, 4, 5. So it looks like it grew by 2 there too. So in this one, I should be, if the pattern's still holding, I should be adding 6. Well, 1, 2, 3, 4, 5, 6. I am. I'm actually adding 6 here as well. So there should be 21 if I add 6. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. It looks like that's exactly what we have going on here. Okay, so now if we had to build out number 4, I would speculate that we would be adding 6 for that as well. So we would have 27 tiles. I could go through and actually take the time to build it in this in here, but I'm not going to do that. We can speculate that this would have 27. It would grow by 2, so it would grow here and here, right? In fact, can I change the color of these? I'm not sure how to add, but I would add 2 here, I would add 2 here, but I would also add 2 more to the length here to get my 27 from this one. Here's where it actually becomes pretty important though, because in my equation, I can see where the 6 is coming from. This 6 is coming from the growth. That's our slope in a line. In a line, it's how much you're growing by, and we're growing by 6 every time. So in that one, I'm really able to see where that 6 comes from. This one is kind of the question mark. Why do we have this plus 3? Why do we have this plus 3? I started, I would think, because that's a y-intercept. If you guys have ever looked at a line before, that's known as a y-intercept. So I would think that's where we start, because that's what a y-intercept represents. But look at, we start with 9 of them. We start with 9 of them. So to me, I would have thought that it would be plus 9 because that's how many we start with. Oh, but wait a minute. It looks like maybe that's why we have a figure 0. A figure 0, if I go to figure 0 now, so I'm kind of like backtracking, right? Like, let's make this a figure 0 instead. If I backtrack from there, I could subtract 6, right? Because I'm adding 6 each time. So if I take 9 and I subtract 6, my figure 0 should actually have 3 of them. Because remember, we need this plus 6 every single time, right? So my figure 0 has 3. My figure 0 has 3 in it. Well, what might that look like? Because here we've got a C. Remember, we're adding 2 every single time on here, and then we're adding 2 here, okay? So the way I might see figure 1, because we're adding 2 to this, and we're adding 2 here, the way I might see figure 1 is I'm gonna take away that one and that one and that one and that one, right? I take those away, but then I need to take away 2 here. Oh, so guess what? Figure 1 for me would actually just be 3 tiles like that. 3 tiles. I'm sorry, not figure 1. Figure 0 would just be 3 tiles right here. So that would hold with the pattern. That is where we get this equation. So now I'm going to bump back actually. I'm going to exit here. So to apply that same concept to what we did in this equation right here in the very beginning, let me move this over, zoom in a little bit. To apply that same concept now to this one, talking about, because we talked about how it grows in words, let's go back and talk about now, how does this one grow in numbers? We said that this grew by 5 each time. So our figure, and I'm gonna actually save a spot here for this one, for 0, 1, 2, 3, okay? Figure 0, 1, 2, and 3. We have in figure 1, because it says figure 1, we had 5 of them. In figure 2, we had 10, and in figure 3, we had 15. They were growing by 5 each time. Plus 5, so we were growing by 5 each time. So in this one, sorry, I have my updates coming up there. So I'm adding 5 each time. So if I go backwards and I subtract 5 to get what would be in figure 0, I would actually get 0. I would actually get 0. So the equation of this one is actually going to be y equals, I use my slope of 5x, and then this becomes plus 0, or you don't have to put it at all. To double check to make sure if you're doing it right, you actually plug in the figure number. So for figure 1, if I plug in 1 for x, I get 5 times 1, figure 1. 5 times 1 would give me 5. If I plug in 3 for figure 3, so I plug in 5 times 3, I get 15 plus 0 would give me 15. Back in this one, so applying that same concept, this is the last thing we'll do. If I plug in 1, I should be able to get 9. I should be able to get 9. So if I plug in 1, I have 6 times 1, which is 6, plus 3 is indeed 9. If I plug in figure 3, okay, if I plug in figure 3, I get 6 times 3, which is 18, and then I add 3, 18, 19, 20, 21. I get 21. It's actually great because now, if I want to plug in and I want to know, what does figure 100 have? How many does figure 100 have? I don't want to go through and build them out. I can actually plug it into here. Figure 100 for this one in the CPM example would be 100 times 6, so I'd have 600 plus 3 more, which would be 603. Okay, so that shows you another way to pattern with these problems, and that's what you guys will be focusing on today, is solving real life problems. Okay, that is all for today. Again, congratulations on being done with your first week.